friends, how are you? Today we will discuss about the spherical mirrors. Spherical mirrors. A spherical mirror is that mirror whose reflecting surface is a part of a hollow sphere of glass. Spherical mirrors are of two types: concave mirror and convex mirror. Consider a hollow sphere of center C. The part of this hollow sphere, this part, whose reflecting surface is towards the center of the sphere, this is called concave mirror. Concave mirror whose inner side is reflecting and outer side is polished. Concave mirror whose inner side is reflecting and outer side is polished. This is the part of the hollow sphere. Now, what is convex mirror? Convex mirror is the part of this sphere whose outer side is reflecting and inner side is polished. Convex mirror is a part of this sphere whose this outer side is reflecting and inner side is polished. This is whose inner side is reflecting and outer side is polished, and this is convex mirror whose outer side is reflecting and inner side is polished. Now we take the example of a spoon in which this inner side of this spoon is considered as the concave mirror and this outer side of the mirror is this spoon is taken as the convex mirror. Now we will discuss about the concave and convex mirrors. Concave mirror whose inner side is reflecting and outer side is polished, and this is convex mirror whose outer side is reflecting and inner side is polished. Now some terms related to these spherical mirrors are: let this center point of these mirrors, this is the pole of the center, this center point of these spherical mirrors are P. This is point P. This is the pole of the mirrors. This is the pole of the concave mirror and this is the pole of the convex mirror. Now the C, center of. Now this is a part of a sphere and this is also a part of the sphere. Now C is the center of this sphere. This is called the center of curvature of the mirror. Center of curvature. C is center of curvature. This is the center of this hollow sphere. This is called the center of curvature of this mirror. In the same way, here C is the center of curvature of the convex mirror. P is the pole of concave mirror as well as of the convex mirror. Now, when we join this P to C, this is the radius of curvature. Like CP, center, distance of the center point from this pole on the mirror, this is radius of curvature. It is denoted by capital R, radius of curvature. Radius of curvature. Distance of pole to center of curvature, this is radius of curvature. Now, what is the aperture? Aperture is the diameter of this reflecting surface. This is the reflecting surface of the mirror. The diameter of this reflecting surface, let it be M, M dash, M, M dash. This is the diameter of this reflecting surface of these spherical mirrors, this is called the aperture. M dash is the aperture of the mirrors. Now these are some important points. Center of curvature of the mirrors. P is the pole. C is the center of curvature. It is denoted by R. M dash is the aperture of the mirror. Now we will discuss about the principal focus of the mirrors, concave mirror and convex mirror. Discuss about the principal focus of a concave mirror. Now consider a concave mirror whose outer side is polished. P is the center of this concave mirror. This is center of curvature, center of this mirror. Now this is principal axis passes through pole and center of curvature. When the light rays fall on this mirror parallel to principal axis, draw the normal from the center of curvature. Now we know, according to the law of reflection, these rays, when the rays incident on the mirror, these rays form the equal angle. Angle of incidence should be equal to angle of reflection. These rays reflected from the mirror and meet at a point on the principal axis. This point where these reflected rays actually meet at a point, this point is called the principal focus of a concave mirror. So, what is principal focus? It is a point on the principal axis when a number of rays parallel to principal axis after reflection meet at a point on the principal axis. This point is called the principal focus of the concave mirror. Now PF is equal to small f. This is called focal length of the mirror. एक ऐसा पॉइंट प्रिंसिपल एक्सिस पर बनेगा जब नंबर ऑफ रेज इस मिरर के ऊपर फॉल करेंगी and after reflection these rays meet at a point. This point is called the principal focus. Now we will discuss the principal focus of a convex mirror. Now consider a convex mirror whose outer side is reflecting and inner side is polished. P is the center of this mirror. This is pole. C is the center of curvature. Now, when the rays of light parallel to principal axis incident on this mirror, these rays reflected and appear to come from a point from the principal axis. These rays diverges from a point F on the principal axis. So when a number of rays parallel to principal axis incident on the mirror, these rays after reflection appears to diverge from a point F on the principal axis. This F is called the principal focus and PF is equal to F is focal length of convex mirror. Between focal length and radius of curvature. Between F and R. Now, it is found that from these ray diagrams, it is found that the radius of curvature R is double than this focal length PF. PC is double than PF. So, PC is equal to PF plus PF. It is equal to PC is equal to 2F because PF is equal to F. PC is equal to R. This is radius of curvature. Now R is equal to 2F or F is equal to R by 2. Now what is the relation between radius of curvature and focal length? Focal length is half of radius of curvature. Focal length is this half of this radius of curvature. Next is the image formation by spherical mirrors. Image formation by spherical mirrors. First of all, we will discuss about the rules. First is for concave mirror, this is pole, focus and center of curvature. Now PF should be equal to FC. Distance between PF and FC should be equal. When a ray, first rule is when a ray incident normal, when a ray incident parallel to principal axis on the mirror, it goes from the focus after reflection. When a ray incident parallel to principal axis on the mirror, then after reflection from the mirror, it passes through focus. In the same way, for convex mirror, pole, focus, center of curvature. A ray parallel to principal axis after reflection from the mirror appears to diverge from the focus. A ray parallel to principal axis appears to diverge from the focus. Now second is when a ray passes through focus. When a ray passes through focus and incident on the mirror, after reflection from the mirror, it will go parallel to the principal axis. A ray passes from the focus. After reflection from the mirror, it will go parallel to the principal axis. Now in convex mirror, when a ray goes towards the focus and incident on the mirror, then after reflection from this mirror, it goes parallel to principal axis. a ray goes towards the focus and incident on this mirror, then after reflection it will go towards parallel to the principal axis. Now next is third rule is when a ray of light passes through center of curvature and incident on the mirror, when a ray of light passes from center of curvature and incident on the mirror, it goes back in the same straight line. It retraces its path because from the center of curvature, a line drawn on this sphere, it is always perpendicular. When the ray incident normally on the mirror, it retraces its path. It goes in the same path. In the same way, for convex mirror, it will be shown by the single line only from the center of curvature. Now next fourth rule is when a ray of light obliquely fall on the mirror at the pole, this is the normal of this spherical mirror, angle of incidence I. It will go along this path at the same angle. Angle I is equal to angle R. When a ray of light incident obliquely, after reflection it will go obliquely along this path. Now in convex mirror, pole, focus, center of curvature. Now a ray incident obliquely on this principal axis at the pole, it goes along this path. After reflection, angle I is equal to angle R. Today we will discuss image formation by concave mirror and convex mirrors in next video.